Hi, I'm Kyle Thompson, and I am in Section 1 of George's June Physics class. In this podcast, I'm hoping to shed some light behind the physics of the forward motion of a toy called a Casterboard. And these toys are better known for the brand names such as a waveboard or a ripstick. Initially, you'd see that they're a lot like a skateboard until you notice that they only have two wheels. Now, when the board is still, it's very hard to stay on because it just tips over, like so. But just like a bike or a motorcycle, once it's moving, the spinning wheels add stability and allow you to balance on it much easier. These wheels are fixed to the bottom of the board on an axis that allows them to spin 360 degrees. Um, the real trick with how the board works is this angle that the wheels are fixed to the bottom of the board. And you'll notice also, which is really important to what I'm talking about, that these wheels actually change height when they spin about their axis. Here they're low, which is where they're at rest, and then up here they actually change height. See? So in order to ride the board, one must place their feet here and here directly above the wheels and move the board actually from side to side like this, and then side view of it will look somewhat like this. Okay. There are really more concepts at work here that I'll go into in depth, but the ones I wish to highlight are gravity, work, potential energy, and kinetic energy. The rider does work by wiggling the board from side to side. Due to the angle of the axis on which the wheels are mounted, this causes the board to raise slightly, building up gravitational potential energy. At this point, we could consider the board to be in an excited state. As with all heightened energy states, they tend to return to the lowest state. The gravitational potential energy then changes into linear kinetic energy as it returns to the lowest state. The force of gravity applied to the rider's mass adds weight to the board, and it's actually that weight that causes the transfer from potential to kinetic energy. Now, all I really need for this experiment is myself, the Casterboard, and a dry and somewhat level surface. So here's what it looks like. So, as I did work, the board built up gravitational potential energy, and my weight transferred it into linear kinetic energy. And as anyone can tell by watching this, there's clearly a lot more concepts at work here than just what I spoke about. For instance, friction. I tried to record a clip of myself riding the board right after it had rained, and even the small amount of water on the pavement reduced the friction so much that the board slipped all over the place and it was nearly impossible to ride. Anyways, thanks to my brother and the internet and my growing knowledge of physics, I hope you now have a better understanding of how Casterboard works.